All right, my name's Steve. This is Kyle, Chris, and Greg, and we're going to talk to you about the Splash Meteor Extreme with automechanical reset and an automatic reset. Automechanical wave action control and automatic reset. So it might be kind of hard because of the weather we've had the last couple days, but try to imagine yourself in a hot summer day. You're by the pool, the sun is out, and basically you just want to take a dip in the pool. So what you're going to do, obviously, is you're going to do a big cannonball into the pool, and that's going to generate a wave. And you're going to come up and you're going to ask your friend, how big was that wave? And he's going to say, well, it was kind of big, I guess. I don't really know. Because it's really hard to measure, how big is a wave? Can you compare a wave between your friend and yourself? Can you prove that you have the better cannonball? So that's what our goal was, to do that. Go ahead. So our goal is to translate wave amplitude onto an easy-to-read scale that you can compare between your friends. So before we explain how to do that, let's just hold on for a second, and we'll watch that cannonball again because that was fun. So we're going to demonstrate it on this this wave that we have here. This is kind of a typical wave that you get, and here is one of our sketches. Basically, what happens is this green piece floats. The blue is like an umbrella, so it kind of has high water resistance, and so as the wave comes, it'll expand. That expansion is translated onto the dial, which kind of measures the cumulative effect of the waves. To talk about how we modeled that more in Pro-E, I'm going to let Kyle talk about our model.
Here you can see that we have, we have the base, which is that green thing, and then our the mechanism, which is the gray, and the umbrella underneath it. And as Steve showed you, when it rests on top of the water, that umbrella will kind of want to hold its position in the water. So as a wave takes the flotation platform up, it's going to increase that amplitude. And if you switch to the other side, you can see the mechanism that we have that's going to convert that into a display on the dial. So you have basically two main parts, a spindle and then the larger gear section. And that spindle has a, well, in our case, fishing line wrapped around it, and that runs down the down pipe to the umbrella. So that's basically what gives us our amplitude control. And as that amplitude increases, or that distance between the two increases, you can go back one more. Oh yeah, that's fine. Anywho, it's going to spin the spindle, and it yeah, you can see it work here, but it'll spin that spindle and move the arrow across. And then we also have a ratcheting mechanism that it doesn't let the arrow fall back down to 0 until you depress a button, which removes ratchet from the ratchet gears, and that's going to reset it. So we have an example, or we have our model, and we'd show you on the model, but we found out that the SLA is not it won't really work for this.
So there were slight disadvantages with the SLA material. We sheared off on our model on our ratchet mechanism and on the gear on the back. It wasn't quite strong enough to support what we needed it to do. Other disadvantages of the SLA material were in just rapid prototyping. There's a lot of contact friction on the, I'm gonna hold this up, on the red piece on the back on the wood. It added a lot more friction to the system than we kind of anticipated, and it was really hard to work with. It wasn't quite as nice as we'd like, but that's just the inherent nature of rapid prototyping. So if we could, Greg's going to tell you some improvements we could make.
Like Kyle and Chris said, we had issues with our SLA material not being strong enough for our needs, as well as generating a lot of friction in our model when we were trying to use it. So in the future, if we had a larger budget, or if we were to produce this on a mass scale, we would want to use materials to reduce these negative effects of the SLA in the wood. So ideally, we would use something like molded plastic that would fit our needs a lot better.
Okay, so we had this off so you can see it better, but this would be on here. The red disc is going to be floating, and so.
Well, as it displaces, of course our gears are broken, but that's what would happen with the working model, and then you would reset it.
Well, and this would translate up the rod.
Okay. It broke this morning, by the way.
Yeah.
Thank you very much.
Thanks very much.
Thank you.